Question number 1, describe the current weather conditions at the following locations. Don't tell me what's happening there. Tell me what the weather would be like if you were at that place. Caleb?
Clear skies and like no rain in between.
Clear skies. Pretty nice day. Okay? And we'll talk more about why that is when we get to number 3, but definitely clear skies, probably sunshine. Now there might be some clouds, but it's not going to be like rain clouds. It's just going to be a calm, nice day. Number 2, or I'm sorry, location B. What's happening at location B? If you were there, what would it be like? Be like, okay. Caden, what do you think? It would be warmer than the stuff around it. And remember, we can't say the temperature of this because we don't know, but the red L tells us that this air is warmer than the air that is surrounding it. All right, probably humid, and with humidity comes clouds, maybe some rain. It's probably not a fantastic day there. Maybe similar to what it's like outside today.
Question.
Yeah.
Why do they have like 1 2 cold fronts? Like they don't.
This is the snapshot of time. Weather's always changing. So this is just on this day, at this time, in this place, at that time. Yeah, pretty nice day. Most of it. Oh, number 3. No, I'm sorry, we're on number 2. What type of weather front is currently passing through location C, and describe how it's made? Go ahead, Wyatt.
A cold front
How do you know?
because it's blue and it has triangles on the outside.
Nailed it. And how is that front created?
When cold air meets hot or warmer air, and the cold air basically wins.
Okay, so we've got cold air pushing into warmer air. Check this out. Ready? This is a southern hemisphere. I'm going to tell you already. Number 4, it's a southern hemisphere. In the southern hemisphere, air always turns to the left. Okay, Coriolis effect turns everything to the left. So we've got air coming from high pressure to low pressure, right? But it turns left. High pressure to low pressure 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 turns left. Does this make sense? All right, now what this means, that's fine. In the southern hemisphere, this is where it's kind of tricky to think about because the cold air in the southern hemisphere comes from the south, not the north, right? Because the South Pole is cold, and their warm air comes from the equator. It comes from their north. So we've got warm air coming in from here, like that. We've got warm air coming in like that. We've got cold air coming in like that. We've got cold air coming in like that. So these fronts form the same way they do in the northern hemisphere. They just kind of happen in the opposite direction. And we'll talk more about it when we get to number 4. But we've got cold air coming from the south, pushing into that warm air coming from the north to create that cold front. And just like Wyatt mentioned, we know it's a cold front because it's blue and it's got triangles. Warm fronts are red with semicircles. Occluded fronts are purple or sometimes a pinkish color. And they have both symbols, circles, semicircles, and triangles on the same side of the line. And then stationary fronts, which we have a little tiny one over here. We've got alternating red and blue and alternating sides of the line with a semicircle and a triangle.
Now, if it's going left and the cold, how will it?
Say that again? They're all being drawn to this central area around the low pressure. So it comes in towards that low pressure, comes in towards that low pressure, and the air masses are forced to meet each other. So the warm air from the equator is coming in and kind of turning this direction. And the cold air is coming in and turning this direction. Now, Just because it's turning doesn't mean it's not meeting along this line. Like I can walk right at you, and I can turn. You can still push me, even though I'm not straight at you, right? Like if I'm walking towards you, you could push me back, or if I'm walking next to you, you could push me to the side. That's what's happening up here. This air is flowing kind of this direction, but this air is flowing this direction, and it's pushing into it. Okay? Wherever these air masses meet, this arrow isn't just the only place the air is. The air is everywhere here, pushing that way. Okay? All right, number 3. What does the blue H near letter D represent? Blue H, what is that thing? What would we call it, Zach? Anticyclone. High pressure center, cooler air, more dense, high pressure. Brings us those clear skies like we were talking about here. Number 4, we already said this is the southern hemisphere. That's South America. How do I figure it out without those arrows that I just had drawn on there? How would I figure it out? Logan? Where would I look? Caleb?
You would look at the low pressure, and then you would see like the cold front and the warm front sloping, the air are turning, and whatever way they're turning, it would go that way.
Like that?
Yeah.
And I'm going to follow the arrows, right? Boom, 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 boom. There we go. So we're going clockwise or counterclockwise? Clockwise, which we know is southern hemisphere. Okay, if you remember these, cyclones, northern hemisphere counter, southern hemisphere clockwise. If you can follow those arrows around, you'll be good to go. Here's another center of low pressure. Here's the cold front coming off of it. Going that way, going that way. Here's the warm front going that way. Boom, boom, keep following it. Boom, boom, keep following it. Boom, boom, clockwise. Okay, if you remember yesterday, our fronts looked, the low pressure there, there was a cold front like this, warm front like this, remember? And we followed them this way. Counterclockwise, northern hemisphere. Clockwise, southern hemisphere. Okay? And it all has to do with that Coriolis effect. The way we just drew those arrows on there a minute ago, where the air rushes towards the low pressure center, turns to its left, turns to its left, turns to its left. Look at the follow the arrows. Boom, 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 boom. Clockwise. Okay?
So is there a reason why the front's curved? Like, is there a reason?
Yeah, just because of that Coriolis effect as the air is spinning, spiraling in.
There isn't a reason why, like, when you see
Yeah, again, the Coriolis effect. Yeah, just because the air is kind of moving in that curved pattern, the way they meet is going to look curved. And again, remember people, this isn't a flat thing that's happening. These are three-dimensional. So we've got air at these low pressure centers that's rising up, cooling down, producing the clouds and precipitation that we see around there. And then that air sinks back down at these high pressure centers. Then it flows along the surface, what we feel is wind, rises, sinks, flows along the surface, rises, sinks, flows along. We got convection currents happening. Okay? Questions? Today, let me show you today's map. Remember yesterday we were talking about, we had a cold front move through, and it had kind of turned into a stationary front. Look at it today. Totally stationary. So this is why, and we kind of talked yesterday, we said, hey, we think, based on what we had seen previously, it looked like this center of high pressure was going to start pushing that out of the way. Well, guess what? It didn't. So we had rain Sunday night, rain all day yesterday, rain most of this morning. It's still pretty dreary outside. Why? Because this stationary front isn't moving. It's stationary. And so all that precipitation and cloud cover that's associated with weather fronts is just kind of stuck over us right now. Now hopefully, which we should see, hopefully this starts to move it. We'll see what happens. Mm-hmm. Right. Yep. Which is what we've seen for the last 48 hours almost. These are the isophones. So this is showing us an area of high pressure. So people that are in this area, they're experiencing nice clear skies right now. Yeah. Yeah, and again, this prevailing westerlies kind of push everything. These things are always cycling around so the low pressure center that this is attached to is like here. So everything's kind of swinging this way. This low pressure center is moving. This has moved a little bit even since the last map update. It was here, and it's already moved a tiny bit. Just, again, because those prevailing westerlies kind of push it. And this is the way weather works. It just happens in cycles over and over again.
So down there, it's like red. Like, yeah.
Here?
Well, yeah.
This?
Yeah.
Warm front. Yep.
So they're experiencing that warm front. So will it move up and around?
This is, yeah, this is kind of a strange one. It's kind of connected to both these areas. We've just got a big pocket of warm air down here that's pushing into some cooler air up here. Probably not. But again, I don't have enough information just by looking at this map to be able to tell you that. So it was funny because I looked at my weather forecast yesterday morning before we started, and it was like, ooh, sunny, sunny, sunny for the next 3 days. And that turned into a stationary front. And when I went to look at it last night, rain, rain, rain for the next 3 days. So I'm guessing this is actually going to start sliding into this way. But again, I don't know that.
How could it move upwards if the wind was going into the side?
Well, because remember, we've got air that's moving like that. We've got air that's moving, whoops, like that. It just depends on a bunch of different factors. Well, there's also, we kind of talked about it yesterday, the jet stream that gets into play here. So that jet stream, depending on how it is kind of dipping and diving as it moves across the United States, can really change things. For example, it could dip way far down in here and then come up this direction, and that would help move weather more northward in some instances. Okay, so and that's the tricky part with these is there's a lot of information that we don't have on here to be able to predict what's coming. And this is one of the reasons why weather forecasting is so difficult. Things change all the time. That little thing?
Yeah.
I believe that's like a front in formation kind of thing, where they're like, hey, we think a front is going to form here eventually, but it has not yet established itself.
Okay, so Florida, it's like clear right now?
For the most part, probably. They might have some scattered showers. They are kind of in this lower pressure system that's down here, but they're kind of in the transition zone between low and high pressure right now. So it's interesting.